Hi, this is Yifan. Now I'm going to introduce my final project, a maze problem. So this is basically the same topic as my final project in class 5210. In that project, I compared DFS, BFS, A star, and reinforcement learning and see how they work in the maze. And this is very simple. You have a start point and try to find way out to the end point in the maze. So I will start with how to make a maze. At the beginning, we have a maze with solid walls. For example, like here, 1 refers to the wall, and we have a start point. Then we have an empty list that we gonna save the wall next to our path to that list. And here we can save these two. We're not gonna consider the wall at the outside of the maze because we're not gonna break them. And then we have these two walls in the list, and we will randomly choose one wall. For example, this one, we try to break this. And here we're gonna check if the opposite side of this wall is still a wall, then we're gonna break this wall. For example, right here is 1, this is a wall, then we can break this. But if it's a 0, this is a pass that we cannot break this, we will choose this one instead. And yeah, after we break this wall, we have the situation like this, and we updated our path and also update our wall to the in the list, and we keep doing this until there's no wall to break. And for example, if the endpoint there's a 1 right here, there's a wall, and we can break this wall. So after breaking this wall, then we have a road from the beginning to the endpoint. So this algorithm guarantees that we can find a path at the beginning from the start point to the end. And because I want to add some more paths, so I randomly break more walls. In this case, we will have more randomness. And here are the result for 4 algorithms. We can see only DFS didn't find the shortest path. It made some detour. And the BFS, A star, and reinforcement learning, they all did good. A star is basically BFS. So BFS is like plotting water to the start point, and water will go to all the directions, and we will choose a shortest path among all these directions. But A star is BFS with a heuristic function. Here I chose L1 norm as the distance from the current position to the endpoint. And every time I do the algorithm, I want to lower that heuristic function, which means it guides us from the start point to the direction of the endpoint. And here is the example time that we used for these 4 algorithms. We can see reinforcement learning took a lot more time than the other 3 because we're gonna train something, so it's kind of unfair to compare with these 3. Because reinforcement learning take much more time, so in the time complexity analysis, I didn't include reinforcement learning. And even though these 3 are all fast, but if the maze size getting bigger, we can see the BFS takes about like 10 times than A star because it need to calculate all the possibilities of the road. So yeah. So and also try some other mazes. The first one is the mazes with weighted area. The other one is maze with random portal. After make some change of the BFS and A star, you will just do it really fast and find the shortest way. So there's no reason to use reinforcement learning. But there's another occasion that maze with fog. For example, if you are in the maze in real life, you cannot see the map of the maze. You don't know. You cannot arrange your way with BFS or DFS. You can only just keep going, and if you find a dead end, just go back. You keep getting this kind of experience and remember how the area around you, and maybe eventually you will get to the end. So here we're gonna train an agent to do this. So in this case, we can only use reinforcement learning. Here I use heuristic search agent, but not. I wanted to try Qlearn, but I used reward to update my scoring system, but it didn't really help, so I just canceled that part. I only used a kind of fixed scoring system, but with a heuristic function. So here we can see I got reward and also penalty uh, based on their action, and here I want to motivate the agent to explore more, so that it will just keep going but not staying at the same area. And also I add a heuristic function, which is L1 norm distance. I got this idea from A star algorithm, so it will lead the agent to the direction to the end. And there's two modes of the agent. The first one is just normal mode. It will just choose the best path, and it will also do the exploration. But if it ends in the if it got to the dead end, you will return to the last decision point. And it will choose another way. For example, there's a way to the unexplored area. It will go that way. So yeah, let's see how it works. Keep going. Oh, there's no that. Oh, okay, he just find is that and just go back and here the same, and then you got the destination. So total, it takes 51 seconds to train, but not the result that I show is the training time is. So the maze size is very small. You can see it's like this, but if I use the maze like this, it will take way much longer time. For example, if I increase the size from the 17 times 21 to 41 times 71, the training time should be around 7 minutes. It's not that long, but yeah. But if the maze size increased, because the time complexity is n square, so it will take way much longer. Here I try to use multi-agent and parallel computing to have different agents that they will help each other, and to see they can find their way out much faster. So in our system, I have multiple agents working as a team to explore a maze. So each agent can see 6 cells around it and can talk to other agent within 20 cells. All agents start from the same point, and they share information about where they have been and which paths are dead ends. So and how often each area has been visited. I use GPU to make things faster by handling all agents at the same time. Instead of processing one agent after another, I get all their informations together and decide all their moves together and update their positions. Okay. So the agent work as a smart team. They do not explore the same area by sharing what they see and knowing where others have gone. So each agent tries to stay away from other agents. In this case, we will explore more area of the maze. And if one agent gets stuck, it will just back up and try a new path. And they can also help other agents to find a new area to explore. For example, if one agent stuck at a dead end and there's another agent nearby, and if it had experience, okay, I know how to go out, it will tell the agent that's stuck at this point. So in this case, we will have something like this. Maybe these two are help each other, maybe these two are help each other, I don't know. So it's basically work like this, and I will show you how it works. training time is very fast. Yeah, it will take some time, but the training time is only like 3 seconds. It's much faster than before. The lines are the recent past. Oops. Yeah, are the recent past. It shouldn't be only horizontal and vertical line. I need, yeah, I need some change for these lines, but yeah, we can see the blue one is near the exit. Okay, you just get the exit. And here's the final pass that we have. This is not the pass that the blue agent actually takes, but this is generated by the shared memory of all these agents, and they find a good pass. I believe this one should be the shortest pass. Yeah. So this is the result. And we can see is much faster because the estimate time we set is 7 minutes, but the training time only takes 2.5 seconds, so much faster. That will be all. Thank you.